Hi, I'm TechneMoira and welcome to my channel. Today the episode is all about the Pioneer GR-333 Graphic Equalizer. I found it in a sorry state on the internet and I refurbished and repaired it to a very nice working state. So grab something to drink or maybe your favorite snack. Lean back and enjoy watching me bring this beautiful little graphic equalizer back to life. I recently acquired the Pioneer equalizer, and as the front panel says, it's a Pioneer Graphic Equalizer GR type 333. And the seller couldn't tell me too much about it. Basically, the only thing the only two things he mentioned was that one of the buttons is missing. Over there, the one labeled equalizer, and that some or maybe all of the lighting of the equalizer wouldn't work. I mean, I think he meant to say that some or all of the LEDs on the front panel do not work. Okay, there's not much to it, to this graphic equalizer. There are just a couple of boards really. So there's this board here with the transformer for the power supply and a couple of fuses. There's a fuse here rated at 400 milliamp, and there's one over there, and I can't tell the rating, but I suspect it would say 2.5 amps maybe. Let's see. Yeah, that one is rated at 2.5 amps. At least that's what the board says, right? So that's the power supply board, and then this is the main board of the equalizer. Obviously this part over here, yeah, there's a bridge rectifier here, so a full wave rectifier and a filter capacitor and maybe a power regulator. I don't know yet. I need to take a look at the schematic. And then a few electrolytics, most of them small ones, and a few ICs. And then the rest is really basically only cable, cables, plenty of cables, and all the cables run to the potentiometers at the front of the equalizer. Okay, so over there, let's see, so all the cables come from the main board right here and run over to two PCBs over there where all the potentiometers and the LEDs are located at the front, right? Yeah, all in all, there's not much to it. So what I propose that we do, contrary to my habit, is that we try to start it up slowly on my Variac over there. Okay, and we have a look at how it functions, if it functions at all. Alright, there are a few simple measurements you can take before starting to work on any device. You know, let's say some quick wins you can get from doing some simple measurements, you know, just to check out if you can find out what's wrong with the device, right? So one of those quick wins is first of all measuring out whether the AC circuit of for example, this equalizer still works, which means, you know, the transformer, obviously, and then the fuses that are inside the device, right? So there's this fuse here, and then there's another fuse over there. So the easiest thing, let's say, to measure whether the AC part of the device works is really quite simple. So you put your multimeter, which is this one over here, yeah, on conductivity test. Alright, so which means that if there's a short between the two measurement leads, the multimeter will say that there is conductivity between both measurement points, right? Let's see what we measure. Let me take you a little bit closer here. So let's see what happens if we measure the fuses. Okay, so let's measure this fuse here first. Okay, that one is good. Then let's measure the other one. Okay, so let me see here and here. Okay, so that is good. So the fuses are good. Okay, what else could we measure? Oh, we could measure the switch itself, right? So let's see. How should I measure that? Yeah, because there are 3 wires running to the switch instead of 2. I don't know quite how it's connected, but yeah, let's see. Okay, so now the switch is in off position and nothing. Now it's in on position. Okay, so the switch works. So the switch works, the fuses work. I was in the process of releasing, or let's say but yes, releasing the print boards, you know, to be able to work on them. And I already released the power supply board, which is basically this board here, you know. And you know, then these are the wires. So I don't know if you see this, but so these wires here run to the bridge rectifier right here. So the full wave rectifier over here. Alright, so this is where the full rectifier diodes are located. So this, we know almost for certain, is the secondary, this here. So let's measure the secondary for a minute, yeah, just to make sure. Oh, okay, there's weirdly enough. Okay, how can I show you this? Okay, hang on. So over here are the connections of the secondary. Let me show you a close-up. So these are the secondary, and there is effectively, you could say, a center tap, quote unquote, but it's not connected to anything as far as I can tell. No, it's not connected to anything, which is a bit weird. I mean, maybe it's sort of an extended ground lead, maybe. So let's measure the secondary here. Okay, the secondary seems to work. So let's see. Well, I'll show you what it measures. So 6.3 ohms. 6.2, 6.3. Okay, so the secondary seems to be working. Okay. Oh, come on. Alright. So the secondary seems to work. Alright. Now let's see if we can measure the primary. Okay. So let me see. The primary. So let's see if the wire itself is good, right? So I mean, there's no point in measuring everything if it turns out that the wire itself is faulty, right? So let's see here, one of the prongs of the AC connector, okay, and then let's measure at the point where the AC wire comes in. So okay, so that connector here on the left works. Let's measure the right one. Oh yes. Yes. So the AC wire seems to be okay. Great. Okay, so then if we know that, then we can move on to the transformer itself, right? Alright, I put my multimeter on AC voltage measurement, and the device, the Graphic Equalizer, is connected up to the AC. So let's see if we get AC voltage here. Yes. Okay, we get 216 volts, which is not very high. Let's increase it a little bit. Yeah. Okay, 226. That should do. Let me show you here. So, there. 226 volts. Okay. So now, let's see if we can measure anything coming out of the secondary of the transformer. Okay. No, apparently not. That is strange. Okay, so let me switch the device on. Okay. Okay, 14 volts on the secondary. Alright. So, in other words, this device is permanently connected to the AC. So there's no, the switch we see here on the left is actually not an an AC switch, or at least not an AC switch for the main power, for the mains, right? It's only a switch which switches the secondary. Aha! Now, strangely enough, I measured continuity on the transformer and I didn't get any sort of reaction. But I could take another measurement which is probably much more accurate, which is measuring the resistance of the primary. Let us try that. Alright, I disconnected the graphic equalizer, so now what we can do is measure the resistance of the primary of the transformer, right? Hang on. Oh. There. Kilo ohms. Here we go. Oh. Okay, let's see. 2 kilo ohm range. Okay. Alright. Alright, so the primary of the transformer goes between 750 ohms from 750 to 500, roughly 550. Okay, so there are two coils on the primary, which makes me think that the transformer can either be used on 110 or 220. The continuity test, or the conductivity test, is good to show you if there is a hard short somewhere or not. Okay, but once there is some sort of resistance involved, then obviously it's better to do a resistance measurement, which is exactly what I did. So now we know the primary of the transformer in fact does work, and we also know now that the power switch doesn't switch on and off the AC side of the transformer, well, the primary side of the transformer, but rather the secondary. Okay, now for your information, I had no look yet at the circuit diagram, the schematic of the equalizer, so I was, let's say, guessing, you could say, or it was just a conjecture of mine that this was in fact the AC power switch and not the secondary AC. Okay, so actually, that's good news. It means that in the end the transformer is good, which is perfect. So now I think what we can do is move on and recap the main board of the equalizer. I took the executive decision to completely unmount everything electronic from the chassis. I mean, it's just a few screws, and all the screws that are holding together the whole equalizer, or nearly all of them, are all the same type. Yeah, and I'm keeping them in little compartments in this box here. And I always put my parts from left to right and from top to bottom. That way I know once the moment comes back to put everything together again, I just need to go in the reverse order to find the right screws, right? Okay, so that's one thing done. So here is the main board of the equalizer, and let me give you a view of it. Yeah, and it's really quite neat actually. It's a very neat PCB. So there you go. This side has all the audio connectors right here. Okay, and one thing should be obvious immediately, is that the audio board right here, this little board here, yeah, is completely separate from the main board. I mean electrically, yeah. Mechanically it's still connected to the main board, but electrically I don't see any traces running from the main board to the audio output input board. Fascinating. Either way, the whole board is really clean. The solder points look clean. I don't see any obvious faults or parts that may have burned through, or you know, have sparked or anything like that. So at first glance everything looks normal on the main board. Alright, I finished replacing all the capacitors on the main board of the equalizer, and I counted them all. So it's 13 electrolytic capacitors in all. So not too much of a chore. I measured most of them. They seem to be still okay, but you know, whenever I go into a device or some piece of equipment or whatever, I tend to nearly always replace all the electrolytics, and for a very good reason. Well, actually two reasons. One, electrolytics are often the source of a lot of trouble in a device. Even a single shorted electrolytic can cause a lot of mayhem. And on the other hand, I really don't want, once it's repaired, a device, I really don't want to jump into it again to repair it again. I want it to stay good for at least a number of years. Okay, so preferably until I die, and then it becomes somebody else's problem, right? So there you go, all the capacitors are replaced. So what I'm going to do now is hook it up to the AC and fire it up again and see if it works any better or differently, and we'll take it from there. Alright, so the device, the equalizer in fact, is connected up to my Variac, and just to show you what does work for now, so the power LED right here, I don't know if you can see this, but let's see. So the power LED in fact does work. Okay, what also works is the tape monitor switch indicator. Let me show you. There. Alright, so the tape monitor switch works as well. Alright, what doesn't work are all the little LEDs which are at the tip of the sliders, you know, the slider potentiometers of the equalizer. In fact, every single slider should have a little if I'm not mistaken, red LED lighting up, and neither of the channels seem to light up. Alright, so these are all the LEDs of the sliders, right? So there's 1, 2, 3, 4, 5, 6, 7 LEDs. So each slider, there are 7 sliders. There are 7 LEDs for each slider. I'll confess that originally I thought every single LED would be like, say, an indicator when a certain frequency would go over a certain number of decibels. But actually, no, that's not the case. The LEDs are just what some people would call a gimmick. Okay, so they just light up and they show you in which position the slider is on the equalizer, and that's it. Okay, so it's basically just a lighting up little LED. Now, what do I notice here? Well, first of all the LEDs seem to be in series. Okay, so see, one after another, and that is actually potentially a problem. That means that if one LED is broken, yeah, then all the other LEDs that come after won't light up either, and that might be a problem. Okay, so then if we follow the schematic down, we come to the other channel of the equalizer, and there we see the same construction. So every slider indicated with its own little LED. Okay, and again, all the LEDs are in series. So then we follow the schematic yet again, and we come right here, here I say, yeah, right here. So there. So this is the power source, you could say, for the LEDs. Okay, so this is where the voltage, the correct voltage, is generated, so to speak, to light up the LEDs. So if there's anything wrong with the LEDs, then it would either be in the output of the main power supply, which is over here, okay, and that should output, according to the schematic, 12 volts or 12.6, let me have a look, 12.8. Okay, so the main power supply should output 12.8 volts, and that goes into the separate little power supplies, or you could say power regulators actually, for the LEDs. Okay, so there's one channel and this is the other channel. So either there's a problem here or at the main power supply up here, or there is the problem that I mentioned, namely that since all the LEDs are in series, if one of the LEDs is broken, then none of them will light up. So on the schematic here you see there's a 10K in series with a 1.2K, and this forms a divider bridge, right? And that should give us 1.3 volts. Now I measured the resistor here, this one here, and it measures almost perfectly 10K. Yeah, it's maybe 30 ohms off or so. So the resistor is fine. So I would say that more than likely there is something wrong with the transistors. Now I cobbled together a string of LEDs, okay, because I don't want to risk burning the LEDs on the front panel. The reason why they used a transistor instead of coupling it directly to the power supply like I am doing is because if you make use of a transistor, you can limit the current flowing through the LEDs far easier. You know, you just need to set the right bias on the base of the transistor, and then you can limit the amount of current easily that flows through all the LEDs, right? So, and that's exactly why they use the transistor to do it, instead of doing like what I did, connecting them all up immediately to the power supply, because that's in essence what I'm doing. All the LEDs are connected in series straight to the output of the power supply. Okay, so now what I'm going to do next is I'm going to unsolder both transistors and then measure them. For those of you who are interested in some practical information and the maths behind my experiment with the LEDs, these are all the electrolytics I replaced. Okay. For your information, this one is an 0.47 and this is a 2.2 microfarad. Okay. So 147, 2200, and a 1 microfarad here. Most of them are 50 volts, some of them are 25 volts rated. In total, 13 capacitors. Okay, so I did the math, and I made the assumption that a mini red LED needs about 1.7 volts at 10 milliamps to light up normally. So like this, okay? So if you multiply that by 7, you get you need 11.9 volts at 70 milliamps to make them light up. Now an LED, also being a diode, silicon diode, already of itself drops about 0.65 volts. So it has an internal resistance, right? So the 7 LEDs in series drop 11.9 volts. The LEDs themselves, so the diode, you could say, that they represent, drop 4.55 volts, right? So if you deduct that from 21.1 volts, which was the voltage I measured from the power supply, you get a what I would call an excess voltage of 4.65 volts for the 7 LEDs, or in other words 0.7 volts excess per LED, which makes that each LED gets 2.4 volts. Now I'm beginning to suspect that that was a little bit too harsh on the LEDs, you know, and that is why they added a 56 ohms dropper resistor on the emitter of the transistors, right? So a 56 ohms will drop at 70 milliamps about 3.92 volts, so which comes damn close to 4.65 volts. Alright, I hooked transistor 1 to my little tester. Now let's see what it says. Okay, it's an NPN and the values look okay. So let's test the other transistor. This is transistor 2, and now let's push the test button. Yeah, it also tests like an NPN, and the values are almost identical to the other transistor. Damn! Okay, so this might mean that the transistors are okay and basically the circuit is okay, but that there is at least one or more LEDs which are broken in the front panel. Oh dear, that was exactly what I was trying to avoid, but well, okay, out they come and we'll have to take a closer look. Alright, I cleaned the left equalizer slider module completely with consecutively contact cleaner WD-40, alcohol, pure alcohol, and then again some contact cleaner, and you know, I just didn't simply bathe it in those products, but I slid the potentiometers back and forth several times, and I also used a cotton stick to clean out the lanes above and below the sliders, the potentiometer sliders, and then I dried it with a hair dryer, and this is how it looks now, shiny and brand new. So now what I did, I hooked it up to my power supply over there, which is off for now, and I also hooked my multimeter in between on the milliamp setting. So we're going to measure the amounts of milliamps the whole thing will draw, right? So yeah, well, okay, so let's check if I set it to 0. No, I didn't, so let's do it. Okay, here we go. Alright, okay, the meters are at 0, the LEDs are off, so let's turn up the voltage a bit, right? I am thinking around 14 volts we should start to see something, you know, according to my calculations. Okay, this is 14 volts, okay. We're drawing, let me see, we're drawing a third of a milliamp, which is very little, but there is, oh wait, I do see some conduction, some lighting up. I mean, yeah, it's very faint though, So let's push the voltage up a little bit. Let's say 14, 15 and a half. Oh yeah? Yes, absolutely. There you go. Alright, so one of the front buttons of the equalizer is missing. Completely missing. But we were lucky in the sense that at least one of the two buttons was still present on the front panel, and I unmounted it, and I'm going to try the same trick I used on the Technics Cassettedeck. Link below the video, okay? But yeah, I'm going to use one of the buttons of the equalizer as a model, let's say, or well, yeah, a model to create a mold in which I can pour some epoxy and then create a new button from scratch. Alright, with the help of a few strips of plastic, you know, like this kind of plastic, okay, and a piece of plastic I cut out of this cap, which I took from a spice jar, and some Captain tape. I made the basic shape for the button, alright? So it has the same footprint as the original button. I also made a few little parts that I might need. Let me show you. Also out of plastic here. Yeah. I'm going to use a slightly trimmed nylon screw as the center pin of the button, okay. Then there's a smaller pin, plastic pin, at the top of the button. You see it there, okay. And for that pin I'm going to use a piece of that little red piece of plastic. And then for the hooks of the original button, I took two of the smallest nylon binders I had, and I cut the top of the binder off and then cut it a little bit with my flush cutter, okay. And I cut it to size, and I gave it a approximate similar shape as the original little hooks on the original button, right? Making a new button with epoxy is turning out to be a really messy job, and although it looked rather straightforward to make, there will be still some, how should I call it, post-production work. There will be some post-production work necessary to make it a usable button. I'm not even saying aesthetically pleasing. I'll be happy if this turns out to be usable. Yeah. I mean, it will be solid. The epoxy I'm using is really rather strong, but yeah, I mean, it's messy to work with. Alright, so here is the tape that we the piece of tape that we will stick to the sliders. Okay, so I'll give you a close-up. Wait, that way you can see what I mean. So there you go. Okay, so the tape parts wherever the slider moves and then closes back up again after the slider moves to another position. Okay, it's not perfect, it's not ideal, but it will do the trick of, let's say, closing the gap a little bit more against dust, right? So anyway, the way I do this is I have a certain measures here on this box, which is perfectly flat, and I measured about the right distance that I would need, the right length of tape that I would need, and then I hold the module, let's say the slider module, right next to the tape, and then I cut exactly down the middle of the tape. I cut a slit with my knife, you know, a perfectly straight slit like this, and I know now from where to where I need to cut. So there, that's about the cut I need. Then I know I can cut it here and it will be the right length. There you go. Now I can peel off this part of the tape like this. Alright, there you go. So the slit down the middle, then I slide it over the potentiometer slider like this, and I try to center the tape, you know, and then I stick it to the body of the slider module like that. Okay, so that's it. Once this is done, it's all a matter of rinse and repeat for all the other tracks, right? So yeah, that's it. And there you are. The modules are ready, left and right. Okay, so give you a little close-up. There. Okay, so that's how it looks like. Okay, granted it's not perfect, but not doing it would make the modules more susceptible to picking up dirt and dust again, and thus rendering them inoperative, right? So this way at least they get some sort of protection against dirt and grime. Okay, so there you go. Both modules are done. All I need to do now is wait for the button to cure over there. Okay, so let me show you. So there, the button is still curing. I touched it not a minute ago and it still feels a little bit tacky, so I have to wait a little bit longer until the epoxy is fully cured. Alright, I soldered back the original transistors which provide for power regulation for the LEDs. So it's those two transistors over there. Alright, and the little resistor at the back on the left has also been resoldered. So now the transistors are soldered back. I guess we can try we can try the LEDs out on the panels, right? Before we mount everything back. So we're connected to the AC. So let me switch the equalizer on. Okay, it was on. Now let's push the button to switch on the equalizer mode. Well, there you go. Nice. Yeah, all the LEDs work. Oh yeah. And they're pretty bright too. Okay, so on to the button that I was fabricating. So originally the equalizer had two of these buttons, rectangular with a number of pins, different pins sticking out at the back, right? And well, one of these is missing. So in my first attempt I tried to make a similar button, let's say, and it's a disaster. I mean, it's no good. I tried to fabricate one out of several pieces of plastic, but the result is pitiful and well, basically unusable. So I decided to rummage in all the plastic parts I had gathered over the years, and I found a few parts that were, with a little bit of adaptation, were quite usable. And the result is this. So this is the, well, almost finished form of the new button. Okay, so no, I know it's not identical, but the size will be identical and it will be a functional button. The only thing I need to do now is shave off a little bit of the epoxy on the right side and then mount these little plastic parts you see here to create a button which is very similar to this one. Alright, so all I'm doing now is waiting for the epoxy to cure, and once it's cured then I will start mounting the final little bits and bobs, and yeah, that will be it. Then we'll have a new button for the equalizer. Yeah, and it actually looks pretty cool. It looks a gun gray, I guess you could call it, and it has a marbling effect, you see. Nice. Okay, I know, it's not looking the same as the original button, but I mean, as long as it is functional and clean and it looks cool, which I believe it does, then, you know, I'm already quite pleased with the results. Well, there you are. This is the original button that was left in the equalizer, and this is the button that I constructed. Okay, and that's how it looks now compared to the original button. It's slightly thicker, but and obviously it's not the same, quite the same shape, but it's perfectly functional. It fits into the graphic equalizer without trouble. I tried it out, so it's a little bit snug, but I hate to make it too loose, you know, because over time when it's going to be used, the button is going to become looser and looser anyhow. So I'd like to leave it a little bit more snug for now. Now, compared to what my first attempt looks like, yeah, this is certainly an improvement, right? Yeah, absolutely. Okay, so this side is not too nice to look at, but the front is okay. You know, it's, you know, marble plastic, and it looks really great. In my eagerness to reassemble the graphic equalizer, I made a mistake. I inserted the right display module one slot too far to the right, you know, and therefore I couldn't mount back the front bezel, and I kept wondering what my mistake was until, of course, I counted the slots and I saw, yeah, I have one slot more than necessary, and I moved the whole module one slot to the left. And now everything fits perfectly, of course. Now you might wonder, yeah, but why the extra slot? Yeah, there's no potentiometer here, or button or indicator. Well, I think this front was originally designed to be used in several models of graphic equalizers. So not only in the GR-333, but in other models as well. Because there's an opening here, which is clearly meant to house a button, and there is no button there. If you look at the front, right, you see that there is no button there. There's a text which says 7 plus 7 independent. Yeah? And there is no slider over there either. There's just a fine line. Yeah? So, like I said, more than likely, this plastic front piece of the equalizer was probably built for several models of graphic equalizers from Pioneer. Alright, one final look inside before I close up the equalizer's case and then give it a tryout. And as you can tell, all the capacitors have been replaced. Everything has been cleaned. And everything has been reinserted with care. So it should function without any problems, right? So there, the reassembled GR-333 graphic equalizer from yeah, Panasonic, right? or I should say Pioneer, sorry, from Pioneer, the GR-333. So all I need to do now is insert back all the little buttons for the Graphic Equalizer modules and put back the cover, and that will be it. So there you go. The Graphic Equalizer is restored, repaired and cleaned, and yeah, from its previous sorry state to its actual state, yes, it's quite a jump. Alright, I'm going to give a little demo of what a graphic equalizer does to sound, right? So I've got on my smartphone a few songs which are royalty free, and I'm going to play parts of each song. There are three, with or I should say without and with graphic equalizer on. Okay, you'll see and hear the difference. When the graphic equalizer is on, all the lights will be on the front panel. If the graphic equalizer is off, you'll hear it, of course, in the sound, and none of the lights except the power light will be lighting up. Alright? So, yeah. So let me start with the first song, which is called The Fur Parade. Alright? So let's start first without equalizer. Okay, I paused the song. I'll start it again. But now I'll play it with the equalizer on. Let me see. Okay. Alright, here we you can clearly hear the difference between the music being played with and without the graphic equalizer. So you could say an equalizer is a bit of a cheating instrument. It allows you to selectively amplify certain frequencies and or dampen others. Okay, and you could say that with the help of a graphic equalizer, if you have a cheap set of speakers like these are, you know, which really have, normally speaking, a thinny sound, yeah, with the help of a graphic equalizer, I can make it sound fuller, slightly better. So you can compensate for, let's say, the poor quality of the speakers with a graphic equalizer. But of course, some purists will say a graphic equalizer is artificial. Yeah, you never hear the true sound of the music if you use and when you use a graphic equalizer. Nonetheless, I mean, aside from that, I just wanted to show you what a graphic equalizer actually does to the sound of a song, right? And as you can tell, it worked perfectly.